Hello students, welcome to the lecture of hydrocarbons. We are studying about the alkanes and till now we have studied about isomerism in alkanes and some preparation methods. Today we will continue with the rest of the preparation methods. So, we will start with the preparation of alkanes from carboxylic acid. So, from carboxylic acid, there are two major methods by which we can prepare alkane. One is the decarboxylation, that is liberation of carbon dioxide from a carboxylic acid, which gives an alkane with one carbon less. And the second method is coal-based electrolysis method. So, let us start. We will study preparation of alkanes from carboxylic acids. So, the first method is decarboxylation. As the name suggests, decarboxylation means elimination of carbon dioxide, that is CO2, from carboxylic acid. So, since we are eliminating CO2, means one carbon is being eliminated. So, the alkane obtained will have one carbon less. Okay. So, in this method, the reagent used is sodium hydroxide and calcium oxide. So, this calcium oxide CaO does not have any active part in the reaction mechanism. It is mostly used as a drying agent. So, in decarboxylation, let us consider this is some group and this is some carboxylic acid. So, how is it written? C double bond O and one OH. Okay. So, what will be its corresponding sodium salt? The sodium salt can be written as C double bond O. In place of OH, we will write ONA. This can also be written as O minus and Na plus. This is in the ionic form. So, the reaction is the sodium salt of any carboxylic acid in presence of soda lime. What is soda lime? Soda lime is sodium hydroxide plus calcium oxide. It will give alkane with one carbon less. See, one carbon has been liberated. Alkane plus sodium carbonate. Let's consider one simple example. Let's say sodium salt of acetic acid or ethanoic acid. Soda lime and heat. So, in presence of sodium hydroxide, calcium oxide and heat, sodium salt of ethanoic acid, that is sodium acetate, this is sodium acetate or sodium ethanoate. it will give methane plus sodium carbonate. Okay. So, ethanoic acid had 2 carbons, but we are having methane here, that is 1 carbon. So, 1 carbon less, 1 carbon is present here. So, we will see the mechanism of this reaction. Mechanism. Okay. So, this was the compound sodium acetate. We have sodium hydroxide in the system. So, sodium hydroxide is Na plus OH minus, right. So, OH minus will act as a nucleophile and it will attack in the carbon of the acid group and this bond will break. So, when this CO bond, double bond breaks, there will be a single bond between CO and these electrons will come as the negative charge on the oxygen and OH is bonded to this carbon and ONA is present as it is. In the next step, what will happen? This is O minus and the corresponding Na plus will exist in the form of a salt again. Now, this negative charge in the next step will come back again and form the double bond and this methyl group will be liberated, that is the carbon-carbon bond breaks. So, what happens? C double bond O is back again. On one side there is ONA and in another side there is OH. And what is liberated? When this bond breaks, there comes a negative charge in methyl. So, this becomes CH3 minus and the corresponding sodium plus will be here. Now, this CH3 minus will take up one hydrogen from here and the OH bond will break. So, when it takes up one hydrogen, this becomes CH4, that is methane. Okay. And what happens here? This becomes like this and one sodium plus and another sodium plus. So, we get methane plus 2 sodium, so Na2 and this is the carbonate ion, so CO3. So, this is the reaction, this is the mechanism of decarboxylation. So, let us see a few other examples. If we will take a cycloalkane in the form of sodium salt and in presence of soda lime and heat, we get cyclohexane, right? And this part will form Na2CO3. So, this was decarboxylation. The next method of forming alkanes from carboxylic acid is Kolbe's electrolytic method. Okay. In Kolbe's electrolytic method, what happens? Aqueous solution of sodium or potassium alkanoate. That means the sodium or potassium salt of any carboxylic acid gives alkanes upon electrolysis. Okay. So, upon electrolysis, the aqueous solution of the sodium or potassium salt of any carboxylic acid will give alkanes. Okay. In this case, we will not get one carbon less, we will get the corresponding alkanes only. But this reaction requires some balancing. So, I am writing this in the balanced form first. Okay. So, 2 moles of sodium acetate in presence of water, and when electrolysis is done, we get ethane along with 2 moles of carbon dioxide, hydrogen and sodium hydroxide. Okay. So, here also we need to know the mechanism of the reaction. So, first of all, the salt will dissociate. 2 moles of sodium acetate will dissociate to form 2 moles of acetate ion and 2 moles of sodium ion. Okay. Now, in electrolysis we know there is anode and cathode. What is anode? Anode means the electrode where the anion goes to. So, anion moves towards anode, and here oxidation takes place. Oxidation occurs. Okay. So, what is the anion in this reaction? The acetate ion is the anion. So, this is the acetate ion. Okay. Now, it will undergo oxidation. So, when the acetate ion, that is with the negative charge, when it is undergoing oxidation, what does oxidation means? Oxidation means removal of electron. When we remove one electron from the negatively charged particle, we will have a free radical. Okay. We will get a radical like this. Now, this radical, what will happen? Now, homolytic fission will occur. So, this carbon-carbon bond undergoes homolytic fission. Okay. So, what will form? A methyl free radical, along with it another radical will come on this carbon. Now, oxygen was already in the radical form. So, now these two will form a bond and this will form carbon dioxide, that is CO2. Now, since we had started with 2 acetate ions, right? So, 2 acetate ions will give 2 methyl free radical and 2 carbon dioxide. This is the reaction that occurs in the anode. Now, these 2 methyl free radicals will join together to form ethane. Okay. Now there is cathode. If reaction is occurring in anode, then there will be something in cathode also. What is cathode? Cathode is the electrode where cation moves to. Cation moves towards cathode, and in cathode reduction occurs. Okay. So, here there were 2 moles of water. Okay. Reduction means addition of electron, right? So, this will form 2OH minus plus 2 free radicals of hydrogen. Now, the free radicals of hydrogen will form H2, and these 2 hydroxide ion combines with 2 sodium ions and form 2 sodium hydroxide. Okay. So, this is the reaction in the cathode, which altogether gives this reaction as a whole. So, this was Kolbe's electrolytic method of preparation of alkanes from carboxylic acid. So, in the next lecture, we will study some more preparation methods and we will move to the physical and chemical properties of alkanes. Thank you.